So good afternoon, everyone. Before we dive in, I'll just ask you a simple question. So how many of you have thought that let's integrate this API and it's just going to be half an hour worth of work and spend the entire day debugging it? Show of hands. Oh. I do see very few hands, and for those who didn't show up, I would say that you guys are very lucky. I'm Himanshu, and I spent 5 years at Atlassian building and scaling APIs that serve thousands of developers worldwide. Today, I want to share what we have learned building APIs that delight both developers and machines as well. So, we'll be talking through what are the API friction points from developers to consumers as well. What are some of the main challenges that are being faced by APIs as well. We'll then dive into contract-driven development on how it can scale your API strategy as well. We'll talk about its life cycle, what are some of the advantages it brings, what are some of the toolings that you can use as well. We'll then explore some of the core design principles that make exceptional APIs. These are principles that are unified across all of the design API paradigms as well. I'm then going to walk you through the API paradigm decision matrix, some of the questions which I asked to myself before we start development of these APIs. I'm also going to present a matrix telling which technology suits best in certain cases as well. And towards the end, I'm going to talk about Atlassian's real world journey on how good API design really integrated us and allowed us to basically integrate Confluence with our MCP server very seamlessly as well. So let's dive into the first section, which is about API friction. So yeah, one of the core problems that causes API friction is that there's inconsistency in API responses. There are different error handling variations that happen. Some APIs return HTTP status codes, some return custom error fields, some throw exceptions as well. And developers end up spending a lot of time writing different integration for different patterns as well. Then there is inconsistent pagination that happens across APIs as well. So some APIs basically wrap them in a data object, some actually result as a direct array itself. There are different data formats as well that happens, and also like there are different field naming conventions which people follow as well. So for instance, a classic example is whether you are using is_active, is active, or is active, right? Now when you combine all of this into thousands of APIs, like it creates a lot of mental block as well. With that, there comes a lot of integration consistencies as well. Services use different patterns as well. So for example, some use RPC style naming conventions, while some use REST style naming conventions as well. With different data, different integration pattern approaches. There are different types of authentications as well. Some used bearer tokens, some use OAuth flow, some use custom headers as well. And when you talk about filtering and query approaches as well, people do different types of filterings in different way as well. Some use query parameters, some use filtering as a part of the post request body itself. Now every integration needs a custom logic over there. What it brings is a lot of context switching costs for developers as well. So developers are constantly facing a decision fatigue where they have to constantly make micro decisions for each integration, thinking about what's the best pattern to use over here. To provide meaningful feedback in their code reviews, they need to be proficient in a lot of technologies as well. For example, if you have a stack which is consisting of REST, GraphQL, gRPC and everything, there's a lot of domain knowledge that needs to be learned across the board as well. With that also, you also have to be proficient in a lot of ID and tooling as well. So for example, Postman offers very good support for testing out REST APIs, Apollo for GraphQL. And then when you talk about different testing strategies as well, there is a mental model shift that you need to require as well. So for example, when you are looking into HTTPs, you look into error codes, but when you are looking into GraphQL, you actually start to look into what is the query complexity that looks like. So there's a massive context switching cost that brings in as well. Now, what all of it does, it creates a very poor developer experience, and that is further amplified when there is no centralized place to do all of a given endpoint discovery. APIs are often not cataloged as well. People don't write specs. There's difficulty in navigating versions as well. People don't know what really some versions of APIs are really offering as well. We also have inconsistent document quality as well. There are inconsistent formats. People write specs the way they feel is there will be some specs which have a lot of info, while there will be some which have minimal info that, okay, this response just returns 200 or 400 as well. All of this creates a large number of support ticket volume and a poor developer experience as well. So constantly developers have to juggle through to understand what is really working as well. So what's the solution for all of this? And that's where contract-driven development really comes into the picture as well. So, yeah, just give me a second. So yeah, so let's first talk about the life cycle of a contract-driven development. Is that when a contract-driven development, you define the contract collaboratively, right? Code is just an implementation detail that it must conform to. As a part of the lint and validate step itself, what you do is you set up pipelines which enforce your company's best practices as a part of those pipelines as well. You generate artifacts in parallel over there so that front-end and back-end teams can start working on it. And then towards the end, you can run consumer tests like contract tests from Pact as well to enable those things as well. Just give me a second. I think there's some problem. Yeah. Yeah. Just give me a second. Yeah. Now, what are some of the core advantages that we get out of contract-driven development is that it brings in alignment from the start itself. Your product managers, designer, developers, and your developer advocates all agree on what you are really building, and there are no more surprises that are midway as well. Secondly, it brings in a lot of consistency across development as well as testing strategies as well, and it really becomes ingrained into your development workflow and becomes automatic. Your linting tools enforce the same patterns, same error formats, other things as well. And your contract defines what success really looks like, so people can test against it as well. Then you can develop things parallelly as well, so you don't need to have your UX teams waiting on the backend API to be available. You can mock those stuff, and with that, you can then go about developing as well. So teams can work parallelly as well, so that's the bigger advantage as well. Now let's talk about some of the tools that are available out there. So, for each of the lifecycle stages, right, you start with contract writing. For REST, you have Swagger editor, OpenAPI editor as well. For GraphQL, you have GraphQL Playground. For gRPC, you have Studio as well. For linting validate, Spectral is an awesome tool that we also use as well. You can define custom rules as per your company's as per your organization's logic as well. Similarly, you have GraphQL Inspector, Bufflint as well. For contract mocking, we do have internal tools as well. However, you can use available tools like Prism, WireMock. Similarly, for GraphQL, you have GraphQL tools, and for gRPC, you have gRPC mocks. For contract testing, we do run a lot of Pact-related code as well, so this really helps us test out. So with contract testing, people can consume our schemas as well, so it checks it on the fly that, okay, whether I am really breaking somebody else as well. There's a lot of custom tooling that we have also built in internally to ensure that there's a backward compatibility in our APIs as well. For GraphQL, you have Apollo CLI checker as well, and for gRPC, you have buff breaking tools as well. So yeah, having a good contract is great, but but what makes that contract really good? And there are three core principles to it, which is be consistent, be comprehensive, and be reliable. So let's talk about consistency first, right? So with consistency, one thing that we get out is that it reduces the cognitive load that is on the developer for integration as well. Consistent naming patterns example, using ID everywhere as a path param really simplifies a lot of stuff, right? In a lot of APIs, what you say is that I have some user and then as a path param, I will have a user ID, like, which is not really required, because when people are calling a user / ID, it implicitly says that, yes, I am going to call the user ID itself. So it reduces a lot of cognitive load as well, right? You need to envelop responses into a consistent fashion, right? It cannot be that some of your APIs are just returning objects while some are just returning lists as well. So inconsistency really brings in a lot of issues as well. You need to finalize a pagination approach that works for you and really stick to it. So for at Atlassian, what we have done is that we have standardized these approaches and said that, okay, you can have, for a paginated conference API, whether you access spaces, whether you access pages, whether you access other types of APIs as well, they are paginated, you will get this consistent format as well. So you just need to write the client code once and and it will ensure that it will work across the board as well. Similarly, what we have done is that we have created consistent error formats across APIs as well. So you need to create consistent error responses with standardized code and descriptive messages so that people actually know what's really happening. The next is that your APIs need to be very comprehensive. Your APIs need to cover what is your domain knowledge. So you need to provide complete business functionality. For example, let's say if we are to look into a conference page has attachments, has comments, and versions as well. So your API needs to be comprehensive to support all of this. Your developers, people who are using the APIs, need to get all of the CRUD operations so that they have the full developer toolkit. So it shouldn't be that they are able to only perform certain types of operations while rest of the operations are not something that they can do. You need to document your request and response schemas very comprehensively, right? You have descriptive messages over there, right? What does a 200 really look like, right? What's the comprehensive? For what are different cases for 400s that you can get? So that really helps a lot of developer onboarding time as well. So they know what they can expect, what are some of the potential problems they can get to as well. And provide real usage guidelines. So there could just be copy-paste examples as well. So you can just get those examples, say that, okay, this is how it works, right? Why don't you just copy and paste it and just use it? So that really helps the developer onboarding. With developer onboard, as soon as developers onboard faster, you get a lot of like traction for your APIs and people build more apps on your APIs as well. The next point is that your APIs need to be reliable, performant, and prevent abuse, right? Nobody really likes an API, right, which works on a mobile network where the network is slow and you click it 3 times and it creates the 3 items for you. Ensure idempotency in your APIs because the network does get patchy as well, right? So similarly, caching is something that you can leverage that ensures that your resources are not being overused as well. There's no issues that are happening over there. Do rate limit your APIs from the start itself with AI now really coming into the fore and a lot of systems now building apps that just scrape data out of it, right? It's really, really important that rate limiting is something that is ingrained into your system itself, right? However, have tiered rate limits for free customers, for enterprise customers and others as well. You also need to be very explicit in what your rate limits are really trying to do as well. So for example, if you look into the Confluence APIs, we give people a lot of headers. For example, the beta retry header tells us that what is the time after which you should retry. So this prevents a lot of unnecessary calls that are being made to your service as well. Similarly, we have beta rate limit, near rate limit, which tells, okay, that you are nearing rate limit, so why don't you slow down, right? If people are rate limited, we tell them what's the exact reason why they're rate limited, and then we also tell them what is the time at which they will be resetting their rate limits as well. So that's the other thing is that you need to ensure that observability is really built into the API ecosystem itself, right? Implement good practices like distributed tracing, structured logging. Structured logging really helps if you are connecting multiple services as well. Distributed tracing is something that is a bit expensive to implement. However, with structured logging, you can figure out the exact flow path as well. So that's really good as well, right? Even with distributed tracing, you can implement distributed tracing on certain error conditions as well. So for example, let's say why are your people getting 500, so what's the request path as well to actually identify the root causes. And implement golden metrics as well. When things really break, you'll really know exactly what broke and where it broke, and that will really help you debug stuff. So now let's talk about the API decision matrix, which will help you answer questions around what is best for my project, and I'll give you a practical framework for it. So start with asking these 5 critical questions before you start development of an API, right? What is your primary use case? Is it serving internal teams? Yes, if it is serving internal teams, I'll probably be fine, right? If I don't have a breaking change policy, because I can just communicate with the internal team if I want to roll out features very quickly as well. Whether I'm building it for external developers, then I have to be really, really cautious that it has a high reliability, and I have to be really cautious that I'm not really breaking things as well. Or I'm building for mobile apps as well. What is your performance requirement, right? Is it something where I'm looking, it's a very, very high traffic, or is it a very low latency application, or is it both that I'm looking at? So, or is it like I'm looking for real-time updates as well? And one of the other important questions is, what is your existing technology stack? Different paradigms do really work out, but it also brings in a lot of operational load as well. So if you are switching to a new stack, it brings in a lot of overhead as well. So be cognizant of that as well. What are your data characteristics? Are your queries complex, or is it simple CRUD operations, right? Is your data model really looking like a relational data, or is it more like a document store, That is something. So your data model really defines your API paradigm. And what are your integration patterns as well? Is it point to point or is it event driven as well? Now, based on the above 5 questions, I have broken it down into 2 slides, 2 matrices, which is first is that let's first talk from an interaction pattern, okay? What really works, right? If you're looking for a simple request response, either of REST, GraphQL and gRPC should work fine. With web sockets, it's a bit tricky because maintaining persistent connections is a bit of a challenge as well. If you are looking for complex data queries as well, for example, you want to load an order page, that order page will first try to get what are all the orders and then try to make calls again and again to get the order. So it becomes an n+1 query. That is where GraphQL really shines as well. So the volume of data that you can fetch in one go improves drastically the network calls. So it really improves the performance over there and the experience over there. With gRPC over there, the issue is that, okay, you'll need to have different connectors to build it. If you were to looking into real-time and streaming patterns, WebSockets do really work as well. For example, real-time chat applications, data streaming as well. So WebSockets shine over there. And if you're looking for asynchronous processing, right, gRPC shines over there as well. Right. Other things can also do asynchronous processing, but it takes a lot of overhead to build those systems as well. The next is around what is the implementation challenges that I am going to face. And first thing is that how easy it is for my developers to actually build this thing. The rest is well known, well-defined patterns. With GraphQL, there are a lot of libraries available, but still it's challenging when compared to REST as well. Same goes with gRPC and WebSockets as well. The other important aspect is the operational tooling integration. With REST and GraphQL, you can reuse a lot of the tooling that is already available. However, with GraphQL, one of the things is that you will need to build custom tooling to check what is your query complexity, are people not abusing your APIs or not. Under fetching and over fetching, these are around data shapes itself, like how much data is being pulled. This is where GraphQL really shines in as well, right? So you can control, you have a lot of flexibility in terms of like how much data you really want to get. The next important point is the security and the denial of service protection. The REST and GraphQL shine over there. You can implement a lot of caching as well. You can implement a lot of things. But with GraphQL, one of the bigger challenges is that there are different attack vectors that people can challenge you as well. So for example, the query complexity, the query depth, people also annotate the same query multiple times as well, make the similar calls so that they are not being able to cache as well. So that's a big challenge to think about as well. Rate limiting similarly is fairly straightforward, well-known patterns across REST and gRPC. However, for GraphQL, one of the bigger challenges is that how do you really define how many objects can you really fetch? An object can just contain 2 fields, an object contain 10 fields, 50 fields as well. So the volume of data really changes over there, and having those computed on the fly is really expensive as well. So you need to build all of that infrastructure for that. Then you also need to think about what is the level of access that you want to provide to people as well. Fine-grained authorizations can be implemented across. However, with WebSockets, the main issue is that enforcement happens at the producer and the consumer level. Once a message is out, you can't do permissioning checks over there. And with caching and performance, REST and gRPC really shine as well. With GraphQL, you will need to build custom tooling to cache some of the queries as well. However, people can still do denial of service over there as well. So yeah, let's now talk about Atlassian's real world journey. So we had to integrate Confluence with MCP. Normally this would have been complex, but our well-designed APIs made it so easy that what should have been challenging became effortless for us. And that's the power of great API design. So one of the first things that we did was that we didn't really need to define any custom model because our schema was really rich with all of the definitions. So our Confluence schema already had business-focused data model that covered the entire domain. So for example, it had spaces, pages, blog posts, databases with their actual hierarchy and relationships. When we integrated with MCP, it could immediately understand Confluence content through our existing schemas as well. We also had performance-optimized APIs, so there were some bulk APIs for certain operations. We also had built-in data validations as well, enums that prevented the people entering wrong values as well. Then one of the other big win for us was that the consistent patterns enabled effortless code generation and review. With AI, we were able to effortlessly generate a lot of boilerplate code, and it was really, really easy for our developers to actually review it. Imagine you are generating an API code where different pagination strategies occur, right? You will have to go look into each of these strategies and see that, okay, has the AI really generated the code what I expect it to be? So this is the power that comes with a consistent design. So we implemented uniform pagination everywhere. There was identical response structure. There were identical parameter patterns. So that ensured that we had single clients which were handling all of the capabilities. And basically it was very easy for our developers to actually review the code itself. The third is that we already had a lot of security mechanisms and like OAuth scopes and rate limits already built into our system, which didn't really require any kind of custom implementation as well. One of the bigger problems that happens is that there are permissions which are very loosely defined, and this can be very over permissive as well, allowing people to extract a lot more data. This can go very unnoticed in a world of AI where they can literally pull a lot of information from you at a very short span of time. So you need to have all of those scopes defined properly. Luckily for us, we had all of these things already defined. So granular OAuth level permissions were already there, like read page confluence, write space confluence. We already had a built-in rate limiting that ensured that APIs are enforcing those limits as well. So there is no abuse in the system that's happening. And also, we also had boundaries like Cloud ID, which ensured that there is automatic security validation that happens for us as well. With all of this, like with the exact schema definitions and things being very comprehensive, it made testing very trivial for us. So we knew exactly what to expect. So the request responses structure, all of them were documented. So we could just say that, okay, reference this thing and generate a test case for me and validate it against it. So that sped up a lot of development as well. We had complete error scenario coverage as well. And we had basically, we weren't in a state where we would require any kind of trial and error testing saying that, okay, you do this, then you get this and do something else as well. So that completely eliminated as well. With this, we come to the end of the talk as well. I'll probably say that your APIs could be somebody's favorite tool, design it that way. So your APIs really have business value. When developers are comparing multiple platforms, they're not just comparing features, they're also comparing what is the integration complexity that I am going to inherit from the system. And when they like really good APIs as well, it evolves the ecosystem. They spread a good word to everybody else as well, asking them to adopt your APIs as well. And if your APIs are too complex, they will be warning against as well. So yeah, with that, I've come to the end as well. So yeah, thanks everyone.
Thanks, Himanshu. You got a couple of more minutes for a few Q&As. Sure. Yeah. Any questions?
How you are handling the bottlenecks, performance bottlenecks with this new MCP integration and bringing in AI within the API scopes that you had, integrating it all together?
So we do cache things very heavily as well. So that really helps as well. And there's a lot of logic that's already built in. So even when you are hitting an AI query, it's not that it's computing on the fly. There are some pre-built things that are already being done and that are being cached as well. So that gets returned as a response as well. So yes, there are some performance bottlenecks, but the teams actually look into all of those metrics. So we have a very good observability across all of Atlassian. So we can go to very minute level details as well to understand where exactly the problems are really happening. And that's where you tackle these problems as well.
Thanks. Maybe one more question. There's just about a minute.
Hey, Himanshu, so you had one slide on the mocks. You were able to generate test pictures using OpenAPI, right? And that solves the problem for schema testing. But I would challenge that it wouldn't really solve for functionality when you have state on the server and the responses are dynamic. So how would you test that? What would be your approach?
So like with the integration test, right? You cannot test for all of the cases as well. So that's a reality, right? Because there are sometimes dynamism as well. And this question is more concerns when there is live data as well. So to do that, what we have done is internally, we have had Postman collections as well, because it doesn't make sense for us to have like thousands of integration tests as well. So what we do is we create a Postman collection, we copy over those tests as well, and based on the dynamism of the data, we actually check, okay, that what is really expected out of this. Now, when we actually run things in production, when we do deployments as well, we run the same test suite. So we have curated some bits of data across our development and staging environment in such a way that those tests really work. So when we do testing, we have automatically instrumented this as a part of our pipeline, that first, as a part of the build pipeline, that mock data gets populated, it runs those tests in Postman, and similarly, when we move those to different deployment environments as well, we run it as a part of basically jobs over there as well. So that's how we ensure that we have a very large coverage as well. So yeah.
Thank you, folks. That's all we have time for. Thanks, Himanshu.
Thank you.